Hello, and welcome to Material Connection's first quarterly materials review. My name's Dr. Andrew Dent. I'm Vice President in charge of material research here. I'm joined with Dr. Gayatri Keskar, who's our materials manager.
Hi, everyone.
So, what we're going to be talking about today and presenting on is a series of materials based upon structural electronics. The materials themselves are based upon our library selections, things that we've sourced over the last quarter, the last 3 or 4 months, and they're all commercially available. We're going to present the materials for review and also allow you to participate, because there is the ability to ask questions in the chat box below. We're also going to give you an opportunity to answer a survey which will allow you to vote on the materials. We'd like you to kind of give us some feedback regarding the sorts of materials that you like, and we'll send that out after the presentation. You can also follow us on Twitter using the handle MaterialCX and the hashtag MCXReview. So, why structural electronics? Well, Material Connection every quarter has a particular theme. We've had engineered naturals. We have one coming up pretty soon called new manufacturing. Structural electronics for us is about materials that enable electronic properties and performance without relying upon a typical computer or electronics box. If you think about your average phone or your smartwatch, it's really just a computer attached to a band. What we're doing here is we're trying to find materials that enable that sort of electronic property, but actually integral to the material itself. We have 3 different categories which we've based our materials upon. The first one is lighting and displays, materials that light up or show in some sort of display. The second category is an area that's more to do with materials that respond to an electric charge, either through movement or alternatively by moving the material itself, and then that causes an electric charge. The third category is what we call wearables. Wearables to us are different from, let's say, your average smartwatch. For us, it's materials that enable electronic componentry, sensors, batteries, those sorts of things, to be available on fabrics and flexible materials. The idea being that ultimately that your computer stops being a discrete object and then starts being integral and incorporated into your clothes, your accessories, your bags. So let's get started. The first material I want to present to you is going to be a display material. So Gayatri, why don't you take us through this one?
Sure. So Kent Displays came up with this new type of LCD where you can actually write on the surface. As you can see here, this is a very lightweight display, and it is resistant to extreme weather conditions, as well as it can withstand tear, impact, and abrasion. This basically comes in a standard black background with green lighting. It is made up of a thin film of liquid crystal, tiny particles which are encapsulated and sandwiched between 2 sheets of special plastic. So it flows in different directions based upon the direction of the pressure that has been applied. Unlike conventional LCDs, which typically use transmissive technology, this one uses reflective technology. So when you touch the stylus anywhere on the plastic sheet, it causes the molecules to arrange and form order, which then reflects light. It can store up to 100 pages at a time in an SD card, which later you can transfer to any mobile device using Bluetooth or USB. And you can easily erase the displayed image with a push of button. In this electric erase, there is a flash of electric field which rearranges the molecules so they are no more reflective. The benefit of this material, it doesn't need any power to retain the displayed image. So it is very energy efficient and cost effective. And it can be used in e-writers as well as toys.
Can I see?
Sure, definitely.
Okay, super light, fair enough. Can I make it flexible?
Yes. So it is typically sold in the form of pre-cut sheets of definite size, depending upon customized file. And then it is pretty much flexible. You can put it in any format you want, as far as you can draw it and then laser cut it later.
Thanks. Okay. So moving on to our second material, I'm actually going to have you present this one as well. Here we go. This is a Gorilla Glass from Corning, but it's a new version, right?
Yes, exactly. So these days, most of our smartphones have Gorilla Glass as a cover glass. But this is a new way of actually using a Gorilla Glass, which is more intended towards customized decoration or commercial branding. So as you can see here, it comes in different sizes. So you can use it either at the back of your cell phone or actually as for your touchpad. So the best part about this thing is it can add multicolors and really photorealistic high quality images with a resolution which is beyond the capabilities of conventional screen printing.
Okay.
So this is sort of a neat way using the proprietary ink technique of Corning to incorporate customized designs which actually requires less processing time and produces less waste compared to the conventional techniques, which make it more cost effective.
Okay. So for us, why this is exciting, of course, yeah, printing on glass, not necessarily new, but to us, the ability to print on this piece of glass allows it to potentially be used as a substrate. What I've got my hand, if you can just about see it, I'm going to wobble it so you can perhaps hear that, is we move from perhaps this sort of durable, printable glass, and printing, in this case, just a graphic image, we move on to printing electronics. So if you can print electronics onto this surface, you can then create circuitry, then potentially also print onto this sort of surface, which is a lot thinner and flexible, enabling then the chance to make flexible electronics onto glass surfaces. So we move from Gorilla Glass to printable glass, from printable glass to flexible printable glass, moving towards a flexible, lighter surface. Okay. Our next one is actually another flexible material. This one is actually an OLED. OLEDs are organic LEDs. You all know about LEDs. They are basically bright points of light. They are solid-state electronics that uses a ceramic or semiconductor to actually emit that light. This version, you can see here, is a organic version. So it's using plastics instead of ceramics. The advantage with that, of course, is you can make it much thinner. This is about the thickness of a human hair, even though there are 20 layers deposited on that surface. It is highly flexible, as we can see here, and the light emitted is a nice, bright, uniform glow from that surface. You may know that OLEDs are already starting to be used in consumer electronics, TVs and cell phones, that sort of thing. But this version is primarily used for lighting. So the idea is to create a uniform full sheet that can be connected just with some simple power. This lights up so you can create ambient lighting through a flexible, thin surface. Okay. That is actually the first section that we have within display and lighting, apart from just one left. I'm going to explain this one. Still thinking about glass. Remember we had Corning's Gorilla Glass. Actually, I'm going to have you light it up if you wouldn't mind. So this material is called Vibrance. Now, you probably know that there exist fiber optics that can be lit up. So we can see here, you've actually got a lit up fiber optic. The difference here is that unlike the fiber optics you probably saw from Claire Danes' dress at the Met Ball, the one where you simply got a power source, a light, and then it flows all the way through to the end where the end actually emits light. This one, you can see the entire length has a uniform color and brightness. That's achieved through using a coating on top of the glass fiber. So this is just a regular fiber optic, the same thing that you get your Wi-Fi information through. But in this case, when they put a laser light through, it emits uniformly along that entire length. Applications for this sort of thing, of course, consumer products. One can imagine perhaps using it for headphones. There have already been some designs out there using this for headphones because it's able to light up those flexible cables. Uses a relatively low power source. Can be twisted and turned and incorporated into other products. But the idea is it's a durable, pleasing light source, different from the regular fiber optics because of that uniform glow along its length. Okay, so those were our first four materials within the lighting and display category. The next category we're going to go through, we're going to present some materials based upon their properties and their ability to either generate an electric charge after you hit them or knock into them, or to use an electric charge to cause them to move. The basic materials are piezo's. You might know about those materials, but these are slightly different in that they're moving more away from the basic idea of a ceramic into something which is flexible and can be manipulated more easily. The first one we're going to try, I'm actually going to see if I can show you a little demonstration. So, the material we have, so actually I'm going to have you hold this up so we can see. Hang on a second. I'm going to try and show it on my phone so we can at least. Okay. So connect to use. Okay. Our display. Hang on. So you can hold that up. So the idea is we have is it connecting? Let's start again. Sorry, electronics always. Okay. Okay, what it should be showing, basically what we're interested in is this little bit of flexible rubbery plastic. The idea is this material can respond with an electric charge when it's stretched or pressed or pulled. The idea is the material can give you an electric charge. So what we should be seeing on the screen, of course, is a number go up, which basically says, yes, once this material has been stretched, there's a responsive electric charge. The advantage you have with that is that now I can use this material as a pressure-sensitive surface. I can also potentially also use it as a way in which I can assess movement within the body. Applications for this originally, it was originally intended to be used by the military such that they put it in the bottom of their boots. So when you walk 20 miles, or this is underneath your boot, you press it enough times and it generates enough electricity to charge a cell phone. A great application for just a regular piece of plastic. Continuing through the area of materials that respond to an electric charge or can then generate an electric charge by their own mechanical deformation. This is an electroactive polymer, relatively simple, rubbery looking material. What's interesting about this is that just by me stretching it or pulling it or pressing onto it, I can generate an electric charge. It will tell me how far I've stretched it and based upon its properties. The advantage with that, of course, is if I'm generating an electric charge by its deformation, applications have been where I can apply this and perhaps onto the bottom of an infantryman's shoe, so after a 20-mile hike, there's enough energy generated to charge a cell phone. Alternative applications are it will actually provide sort of a response when stretched or touched. So it can be used as a pressure-sensitive material, able to assess movement within the body. One can imagine applying this onto a fabric, so every time you move, it's giving you information about that movement. Electroactive polymer, available for a number of years, but this first time they've really had commercial applications for this type of material. Relatively low cost because the advantage is, again, it's a polymer. You just need to connect up the end and then it will actually read those responses. Our next is actually also a sort of the same type of material, but this one is where they're applying the material more as a pressure-sensitive surface. So it's a polymer. It incorporates into the polymer a piezo ceramic, so they're adding small parts of ceramic that do have that property of pressure-sensitive response, adding it into a polymer and then applying it on the surface. One can imagine applications for this material in, let's say I wanted to cover the surface of a couch. It would then be able to respond to me. So if I was interested in posture, so by simply applying it onto this surface, the piezo property allows me then to assess the way I'm sitting. So applications there become many simply because I can then very easily and quickly have real-time responses about information about my movement in posture or just simply as a touch-sensitive surface. Okay. The third one in this group, Gayatri is going to present to us, and it's a material called a pressure sensor by sensing techs.
Would you mind holding this one?
Sure. Okay.
Great. So taking the one step ahead, we can also integrate this into a textile, where it can actually measure the pressure as well as the position of the textile, where the pressure has been applied. So in this case, I'm going to give you a quick demo of this. So if I press in the center, you can see in the pressure map, it comes with an app where you can see in the pressure map, it's showing the pressure points where the pressure has been applied. And so it shows the XY coordinates of the pressure points as well as the color indicates how much is the intensity of the pressure that has been applied. So the warmer color means the higher intensity. So these can be used anywhere in a wide range of applications like mats, upholstery, in sheets, cover, wherever you want to track in kind of traffic or use it for measuring the pressure. And the way it works is actually it has integrated conductive inks which can be applied to any kind of patterns or shape. So it can be easily adapted to any kind of textile or fabric you can choose, you can want. And then it gives you much more flexibility because it is incorporated in a textile. So it is much more flexible in that way.
Okay, so whereas my other examples, those were polymers that I could apply as a coating, this one's an integral conductive ink within this textile.
Exactly.
I can stitch this into other garments, other fabrics?
Yes, you can.
Okay.
Yes.
What sizes? Can I get is there a size limitation?
Actually, there are no practical size limitations for that.
Okay, so I can cover this entire couch?
Yes. You
okay.
Can.
Thank you. So that was our third within that second category. We then want to move on to the category of wearables. Now, for a lot of people, wearables simply just means a smartwatch. But for us, as I mentioned earlier in the introduction, it's about how do you have materials that can enable us to have electronics that no longer have a discrete sort of black body or as a discrete object. Moving away from the object such as a phone and moving towards seamless, integrated, flexible materials that can still do the same sorts of things. So of course, in order to do that, what you need is flexibility. You potentially need washability. You need lightweight. You need applications which are durable enough that if I sat down on it or if I bump into something, they can survive. You lose some of the fragility of this type of device that if I knock into it, it can really quite easily break. You need to move into a robustness where the materials can withstand everyday use. So we've got a selection of materials that do that sort of thing. I'm going to start, first of all, with battery power, because if you think about wearables, you're going to need a whole range of different components in order to create that electronics. Think about a basic electronic component. You need battery, you need wires or some sort of connectivity, you need sensors and displays. So we're looking at all of those materials, but in a much more flexible, lightweight and robust version. My first one is a battery. Now this, we've actually created a design of basically a paper plane, but that basically it's kind of what it's like. In terms of its flexibility and flatness, this is kind of the same sort of material that you expect from a piece of paper. It can be folded, it can be bent, it can be scrunched up. It has similar power availability, let's say to a 9-volt battery. But the idea is now, because of this flexibility and this flatness, one can incorporate it into accessories and still have that same sort of power. It's rechargeable, and it has the ability to be flexed and bent over 200,000 times without any loss of power. So you're starting to move away from big objects as batteries, as discrete objects, and into things which is a lot more flexible, a lot more discrete when it comes to application into things such as wearables.
Does it have any kind of size limitations?
Currently, this is their current size. I can imagine, the simplest way to solve that, if you wanted something bigger, is basically just ply a whole bunch together. So if you think about, a large surface area, again, let's think about the couch. I could put, let's say, 20 on this surface, and I get 20 times the power outage, or 20 times the longevity of that battery. Okay. So our next one is a material. It's actually moving away from batteries and more now into displays. The next one is a material called ebrary. I'm going to have Gayatri present this one. I'm going to help her because I need a power source in order to have it light up. So you take that and I will power it up.
Thank you. So incorporating light-emitting diodes into the fabric is not something new, but incorporating it into something that delicate and thin and making it like a fashion apparel is really interesting for us. So as you can see here, they use a proprietary technology called embroidery, which allows you to combine active lighting along with the fabric without losing its drape or strength. So in this case, actually using standard techniques such as sewing and weaving, you can incorporate these conductive yarns and miniaturize LEDs into a fabric. It can actually withstand the regular wear and tear, and you can also wash it multiple times. Only keep in mind to carefully disconnect it from the electronics and hand wash it.
Sure. So, okay, so I can hand wash it. Any limitation on design or fabric? How do I decide what sort of pattern I want? Is that with the manufacturer themselves?
No, actually, so the type of the fabric or the color of the fabric and the pattern of the embroidery is completely customizable. Okay. So depending upon what design or what project you have in mind, you can completely customize it.
This to me is exciting, I think, because it is a combination of engineering and design. Very hard to do often in a lot of the e-textiles we've seen. So it's a great combination where you've had some good engineering, incorporating the LEDs into the material, but also to make sure that the material itself is attractive to designers. So I think it's a good combination. Okay. So our next one is going to be hard to see, but I will try and show it to you. Okay, so, and the whole point is it is hard to see. So what I'm holding up is actually a touch-sensitive surface. This is an alternative to your standard, what's known as indium tin oxide, which is your standard touch-sensitive surface on your phone. This one, the difference is it is flexible, and that advantage, of course, means that I can create touch-sensitive surfaces on flexible electronics. Another advantage of this is it is incredibly thin. The most recent version of this one, which is called CNB, is 12 microns thick, which is about 1/10 of the thickness of a human hair. So super, super thin. The other advantage is, as well as being flat and flexible, I can mold it. They have versions which can be molded over a surface. So in the same way that you have in-mold decoration over the back of your phone, or which creates a three-dimensional effect, you can do the same thing with this. So your touch-sensitive surface no longer needs to be flat. It can now be flexible and also textured. The process they use is actually using carbon nanotubes. It's a commercial application for carbon nanotubes. The carbon nanotubes are applied onto the surface, but because they're so thin, they're completely transparent. So the transparency of this is very high, but also you have good connectivity. So you've got tiny, tiny carbon nanotubes on that surface, making sure there's connectivity, so every time I touch it on a finger, with my finger, it can be able to respond and knows where my finger is, but it's transparent because the nanotubes themselves are so small.
So what kind of applications you can use this for?
Basically making touch-sensitive surfaces on anything. So because it's plastic, it can be molded onto surfaces. So if you think about, one could potentially make a touch-sensitive surface on the outside of this water bottle. So it doesn't limit there. So I think they're looking at, obviously there's applications in toys, there's applications in consumer electronics, but I think their first hope is to move into the flexible electronic space where you've got phones or displays and that sort of thing, which do have flexibility. Okay, our next one I'm also going to explain. This one's a little bigger, so we've gone from very small and hard to see to something that's very obvious. Now, we talked about how do we connect? How do we connect the electronics from the battery through to the display? The simplest type of material is conductive inks. We've seen quite a few of them out there. We have quite a few in our library. This one we like because it displays or shows how the format can change. If you think about wiring, you're always thinking about things such as this, which are thin, but also very discrete and in a particular format. You move into conductive inks, and suddenly the format changes. The format changes such that I can cover this entire surface with the conductive ink, and simply just by pressing on a simple 9-volt battery across that, you can see that it lights up. So this is using the sheet of material as conductive material. So it's a good example of showing the different format one can use when you're using inks rather than wires. I think the company itself, a Japanese company, they do designs, but you can also have custom designs, which allows you to have different types of patterns. Of course, you always need a positive and a negative in order for this the circuit to complete. Okay. Another one within the same area, within conductive inks. So inks not only need to be flexible, but if you're going to put them into a garment, especially a sports garment, they need to be elastic as well. And elasticity is typically the death knell of any electronics. If you think about the average piece of wire, if I stretch this wire, I'm going to lose connectivity. It's going to snap. So advances within the types of conductive inks, this one's actually from DuPont, allows these connectors now to be much more elastic. So I can now apply this onto a stretch fabric, like a lycra, some sort of wearable outfit, and then I can stretch that fabric during my normal movement, and the connectivity still remains. It's not easy to do. It is a very particular type of formulation. But you'll also notice, if you can see this image, you'll see here they've actually created a line here, which is just like a basic piece of wire. But the top one has green on it. And the reason why it has green on that surface is because you need to protect it. In the same way that you sheath a piece of wire so you don't short it out or get electrocuted, you have to do the same thing here. So when you apply the conductive ink onto the surface, you then need to apply that top layer of insulative material in order to make sure it's insulated. So that just shows you the design. So stretchable, flexible, certainly very lightweight, and much more adaptable than a regular piece of wire. Okay, we've got a couple of products now that Gayatri is going to present to you, which kind of show where we've sort of moved in terms of these types of electronics, where we're seeing actual applications. So our first one is a baby monitor. So Gayatri.
So here actually Mimo has come up with a way to track the sleep activity of your baby. So this is actually designed specifically for new parent who want to stay connected with their babies irrespective of whether they are in the same room or across the world. It comes with an app where it gives you insight into baby's sleep activity, how is the quality of the sleep, the baby's body position, body temperature, and breathing. So it can actually give you custom alerts about baby's sleep activity, which could be including irregular breathing, wake-ups, rollovers, anything which will happen during their sleep. You will be able to find out more about it. It can directly be sent to your smartphones. And so what I have here is actually very cute Minomos. What they call it is like sort of a 1C. It is available in the 0 to 3, 3 to 6, and 6 to 12 month sizes. And it comes with a turtle, which is actually the sensor. So it has integrated it into the fabric, and using these conductive ink patterns which you see in the green, it can measure the baby's heart rate too. The good thing about this thing is it is made up of 100% soft cotton. It is washable, and you can also dry it in the dryer at low heat. And this turtle is 100% water resistant and chew safe. So it is made in keeping in the mind how babies will react or interact with this thing.
It's interesting, actually. I know we've seen this type of technology before, but really only for professional athletes.
Right.
A good example, of course, is Adidas My Coach, and also Under Armour came up with that as well, where basically the idea is that you have a apparel, then you have a sensor which can track your movement, whether you're sort of turning around, your force, the speed at which you accelerate, all those sorts of properties. So it's interesting, it's gone from professional sports now down into baby products.
Exactly. So the way it translates or shares the information is it has this pad, so it communicates with this one using the lowest power available Bluetooth, and then it sends information to your smartphone using your Wi-Fi home router.
So basically, what you've got some printed inks here, which are then close to the body, and then you can get some information from basically that connectivity.
Right.
Okay. And our second product is actually it's a patch. You're going to explain our patch to us. So it's small, so you'll have to kind of like actually, if you wouldn't mind wearing it, so we can demonstrate it.
Definitely. So La Roche-Posay, along with healthcare technical company MC10, co-developed this first of its kind UV patch, which I'm going to wear it.
Okay. Okay, is it sticking on?
Yeah.
Hopefully. This is the first time we've tried it. This is actually this is not available on the market just yet. This is a good example of something that's really just only come to commercialization.
So what we have here is actually integrated. What we have here is actually integrated blue-white colored heart-shaped UV patch. It has 5 different layers. It has an adhesive layer which holds everything together. The second layer is photosensitive dyes. Then it has a near-field communication array and an encapsulant for that. And the last one is, as you can see, the clear adhesive which you can stick anywhere on your body. So in spite of this multi-layer design, still it is very thin, so that way it is really stretchable and very flexible, bendable. When you put it on your skin, you don't feel like you're having an electronic device on your skin. It feels more like a secondary layer. And that is because it is so thin. It is actually thinner than a single strand of your hair. And the way it works is when you go outside in sun, it will change the color based on the UV exposure. So it comes with 2 apps, one for Apple and one for Android devices. And in case of Apple device, it has a camera mode, so you can snap the picture of your UV patch when you go outside. And based on the change in the color of this UV patch, as well as your baseline skin tone, skin type, and whether you have already applied sunscreen or not, it will take all that into account and give you a real-time sun or UV exposure. So the great thing about this is you can track it anytime you want, as many times as you want. And it will give you a personalized UV report towards the end of the day. So that will tell you what was your exposure throughout the day and at what time it was maximum. Okay. So it is a very neat way of having something which is so thin and wearable and stretchable. And once it's applied, it can last up to 5 days. And it is completely water resistant And the great thing about this, it is completely free. So there is no initial cost as well as no ongoing cost. So L'Oreal will make it available later, and the app will be available, or actually will be launched tomorrow. So anyone who's using Apple or Android will be able to use this patch and track down their real-time UV exposure.
Okay, so you mentioned an app which was to do with photographing. Is there another way of accessing the information?
Yes, so in case of Android, what they have is the near field communication array. So it works pretty much similar to your Apple Pay or Android Pay. So once you get your phone close to your patch, it will connect with it and communicate and share all the information it has stored so far for you to understand what your UV exposure was at that particular time of the day or throughout the day.
I see. Okay. Thank you. Okay, so for those of you who just joined us, you're watching Material ConneXion's first quarterly review called Structural Electronics. If you're interested in asking questions about our review, you can fill them in the chat box below. And also, if you want to follow us on Twitter, you can use our handle MaterialCX. Okay. So the materials we've presented, it's kind of 15, were intended to kind of show you the highlights of the sort of technologies that we have reviewed over the last 3 or 4 months, which are as part of our structural electronics. I think what you have seen is a range of commercially available materials. But I think most important aspect is what you'll notice is of the materials that we presented to you, very few were sort of a nice convenient box or integrated system. And what we found a lot of the time is a lot of these technologies, they need to be part of a system in order for it to work well. I mean, I think that the patch is a good example. That's a system but on a very fine scale. But a lot of the other materials need to be added into something else. So if we take, for example, as we had seen before, the flexible battery. The battery needs to be incorporated also with some wires. So it needs to be connected to some printed electronics. It needs to be connected into to a sensor. So the materials that we source tend to be discrete and small and in a way perhaps not that, I guess, sexy because they're not a working system. The idea is that we can provide you with the tools and the raw materials within our library that can then allow you to build the system. So you work with the flexible battery manufacturer, you work with the printed electronics manufacturer, you work with the company that can produce the lighting displays, but you will also need other aspects. So the idea is that the library itself, rather than giving a finished product, as we saw with things such as the baby monitor and also the patch, it's more components that can be applied together to create a system. So that kind of wraps up the materials that we had. Hopefully you can get an idea of the way in which we're sourcing materials. This is the way in which we'll be doing it ongoing. You can tune in next quarter. We'll be doing the same sort of presentation, new materials, different theme, the same idea though. So that kind of concludes the presentation part of this the webinar. But I think we should be open to taking questions. If anyone's typed in questions, we'll be happy to answer them now. Okay. I'm getting questions through onto my phone, so if you wait a second as they come in. Okay, so my first one was, so the question was, it looks like wearables was our biggest category. Do we have a lot of clients interested in wearables? And also, what industry are they in and how are they using them? Yes, wearables is the largest category because we have clients who are interested in developing systems where they can incorporate electronics into their current products. As I mentioned, the interest is in lightweight, flexible, seamless. So that's definitely an area that our clients are interested in. We have seen our clients very interested in how we can print electronics onto their current apparel or onto their sports shoes, onto accessories, even onto furniture. So yes, that's definitely an area that we've found a lot of interest in. And because our clients are interested in, again, not removing the aesthetic of a design, wearables are able to do that. So you can maintain the smoothness of a surface. You can maintain the aesthetics, the appearance of the product. You don't need to compromise by sticking a black box or something which looks like electronics onto that surface. The idea is you can make it integrated into your design. You maintain the quality and aesthetic of your design, but the electronics are still there underneath, seamlessly working there. Okay. The second question is, how did you choose the 3 subcategories for this webcast? Do you want to answer, like, I guess it was basically materials that we sourced, we had to sort of group them together in the ones that work best.
Right.
Is that fair? Okay. So yeah, so for us, you know, sourcing materials, we look everywhere. We have our various different offices around the world who are doing that sourcing. Some of these materials actually came from, we had the flexible OLED and the piezo came from our Milan office. They've been working with some companies there and sourcing those materials. So it's very much about what materials we can source at that present time, and then we organize them. We've made a business out of curating and organizing materials to make them understandable and sensible to our clients. So for us, it was just natural to take the range of materials you saw today and find groups in which we can, into which we could organize them. Okay. Apologies earlier on for the technical problems that we had. This is a live stream. It will be available that you can actually download, so you will be able to see an edited and a better version, which does not include some of the technical difficulties. And we'll provide a link to everybody who did log on, and so we can provide that to you a little bit later. I want to remind you also that there is the survey that we'll send out. We'd love you to vote on your favorite materials that you saw today. And of course, you know, if you have any questions regarding that, you can either access it at our Twitter handle, which is MaterialCX, or you can access directly at materialconnection.com at the email news@materialconnection.com. So just left to say thank you very much for your attendance, and yeah, that's about it.
Thank you.